Hi everyone, welcome back to the channel. I'm the GCSE science teacher, and in today's video we're going to be talking about density for GCSE physics. If you do enjoy the video, feel free to give it a like and subscribe. It'd be amazing to have you as part of our community here, and please do share it with anyone else you think would benefit from learning more GCSE physics. So like I said, density is what we're talking about today, and we have to actually go back in time to understand density completely. And if we go back in time to around 200 BC, and we look at the mathematician Archimedes, who was in Italy at the time, he kind of was one of the first pioneers to really understand density completely. So his story is quite interesting. He was actually seen as someone who could understand the world and use maths to explain it. The king at the time, he wanted a crown made out of a specific amount of gold, but especially at that time, the goldsmiths, the people who are making the crowns and other jewelry, they would often replace some of the gold with a cheaper metal like silver. And there was no real way of actually determining if that had happened or whether someone had used all the gold you wanted them to. But the king was quite suspicious at the time, and he asked Archimedes to figure this out. Anyway, Archimedes, he had a lot to do, was figuring things out, and he went to one of the Roman baths, one of the public baths, to think this through. And as soon as he got into the bath, he noticed the level of water rose, and he screamed out, "Eureka!" because he'd figured out what had happened and how he could figure out whether all the gold was used. Eureka actually translates to "I found it," which is kind of exciting because it means that you found something, you've understood something. So what Archimedes did, he found the amount of gold, the exact mass of gold the king had used or wanted to use for the crown, and he saw the amount of water that had been displaced. He then placed the crown in the water and noticed that there was less displacement of water, meaning the crown was actually less heavy, or the density of the crown was less than what was anticipated. This meant that there had been silver replaced instead of the gold. So that was a really cool way that he figured that one out. So in everyday life, you've actually probably seen density before. If you actually take the example of oil and water, you'll know that those two substances don't mix. And it's because oil often floats on the top of water, and that's because it's less dense than water. And it's simply because of how the atoms in that substance are arranged. So if we go back to basics and we look at solids, liquids, and gases, you'll see that solids often have much more dense structures. They have more particles in a given volume or a given space, whereas a liquid has slightly less particles and a gas has even less in that given volume. But in the case of oil and water, you could say, well, hold on a minute, they're both liquids in this state. They are. However, oil is much less dense just because of the arrangement of those atoms, and it essentially is why oil actually is on top of the water. If you mix them together, they actually separate due to their densities. And in terms of the GCSE exam, you will need to know that density, like I said, is the mass per unit volume. It's how much substance is in a given volume or a given space. And we can actually calculate this using the following equation. So we can have density, or rho, which is the symbol for density, equaling the mass of something divided by the volume of something. So the mass is often measured in kilograms, the volume is often measured in centimeters cubed. However, you could be expected to rearrange this equation. You could also be given the mass in, say, grams and need to convert it into kilograms. Those are the sorts of things they could ask you in that exam as well. So I've just said to you that solid substances are often much more dense than liquid substances, and this is because of the arrangement of atoms in those different states. However, we know that liquid water is more dense than solid water or ice. And the question is, why is that? Why is it that water in a solid state is much less dense when other solids are more dense? And the reason for this is because of the arrangement of atoms. Hydrogen make hydrogen bonds in the water molecule, and those hydrogen bonds in a solid state are actually much more rigid. In a liquid state, they actually will break and reform. And because of that, the hydrogen bonds in the ice will actually form kind of like a lattice hexagonal shape. And that essentially pushes those atoms apart from each other, making it less densely packed, which is why ice as a solid is much more less dense than liquid, and which is why ice floats on water. Okay, so there are two parts to this practical, and it's because you could get asked to work out the density of a regular object or an irregular object. And the method for which you're doing depends on what the object looks like. So, first of all, if you are using a regular object or they ask you to work out the density of that, you'll need to still use the equation density equals mass over volume. But in the case of the volume, you would just need to use the equation that helps you calculate volume. So, in this case of, say, a cylinder, you'd use pi r squared times the height. In the case of a cube, it would be length times width times height. The same with a cuboid as well. And so on and so forth. However, often in the exam, they won't necessarily say it's a regular cuboid. They'll just say a regular shape, in which case go with the simplest one, say a cube. You could just do the length times width times height. It doesn't really matter too much. However, if you are wanting to do this for an irregular object, you'd actually need to calculate the displacement of water after placing the irregular object in the water. So there's two different pieces of equipment you could use. You could use a Eureka can, which actually gives you the displacement of water quite easily. However, another way, one which you may have done in class, is using a measuring cylinder. All you'd need to do is fill up the measuring cylinder with some water and note down or record the initial reading, place the irregular object inside the measuring cylinder, and then record the final reading. And to work out the difference of the two, take the biggest reading minus the smallest one, and that displacement reading is the volume of the irregular object. And that's what you're going to use when you put it into the equation afterwards. So it just depends on what type of object you're using, what type of equipment you'll use. But in both cases, you'll need to use the equation rho, or density, is equal to the mass divided by the volume. Just remember as well, if you are doing some maths in this question, you want to make sure your units match up. So if you are using a top pan balance to measure the mass, you're often going to be using a unit of grams. If the question is asking you to convert into kilograms, you obviously need to do that conversion as well. So just be aware of that when you are answering those questions. And that's it from me. Thank you so much for your time today. I've been the GCSE science teacher and you have been curious. If you did enjoy the video, feel free to like it, share it with someone else, and subscribe. Thank you so much if you already have subscribed. I'm so excited to see my channel grow and our community build. So thank you very much for being a part of that. In the meantime, if you want more videos from me, I have playlists and some videos over here. You can also check out my social medias on this side of the screen as well. And I hope you have a great day. I'll catch you in the next one. Take care. Bye.